All right, number three. So this one, same as number one in terms of the directions, except instead of saying find y prime, it says find dy dx. And so once again, same thing though, right? Those are synonymous, interchangeable, for all intents and purposes. Definitely on this test. So, all right. So let's see. First thing we're gonna do is ddx this thing. This time we have some trig involved, so that'll make it a little more interesting, or at least a little different. So the derivative of x with respect to x is just 1. The derivative of 2x cubed is just going to be 6x squared. The derivative of 3 is 0, so that just goes away. The derivative of secant of 2y. So first of all, this is a lot of people in quiz 6 thought of this as a product, but it's not a product, right? It's secant of, like this is inside of the secant, right? So you never have just a trig function alone multiplied by something. Like a trig function always has to have something inside of it. And so what this is a chain rule, right? We have a function here within another function here, right? So what we can do is chain rule. So we take the derivative of the outer function first. So the derivative of secant is secant tangent. And we just keep the insides the same, right? So it's still going to be 2y squared, okay? So that's the derivative of the outer function. We kept the inner function the same. Now we have to multiply by the derivative of the inner function. So the derivative of 2y squared is just 4y, right? And then, since it's a y function and we're taking the derivative with respect to x, we tag on a y prime, or you could put dy dx there, okay? All right, and so now we really just have one more step. Just going to divide this on both sides, right? Because this is all one term here. So I just want to get rid of this part of it. So I'm going to divide that on both sides. I'm going to put the 4y in front just to, that's kind of traditionally where we put things in with trig functions. We put coefficients and variables in the front just so they don't get confused with what's inside of them. Okay, same thing on this other side. 4y secant of 2y squared tangent of 2y squared. Okay, so this all cancels out and we're just left with y prime. So we get y prime equals 1 plus 6x squared all over 4y secant of 2y squared tangent of 2y squared. Okay, and here in this case, there's nothing. There's nothing really to cancel out anyway. But since we have a binomial here, we wouldn't be expected to reduce anyway with that because it would involve factoring. So that's it. That's our final answer for dy dx. It's not necessarily the most friendly looking answer, but it wasn't that bad either, right? Just a couple steps there. So, but just take note of how to do this trig stuff, right? And remember, secant, the derivative of secant is secant tangent, so it's a little different than some other ones. Like you don't always have two trig functions there, right? And this isn't like secant multiplied, like the derivative of secant is secant tangent. And so that's why we have secant and tangent. It's not always like itself multiplied by something else. It's just keep that in mind. That's sometimes confusing, I think. So remember, like the derivative of sine is cosine. So if that were a sine, we would just have one cosine there here, and we wouldn't have this other trig function.